Hello, this is DVKT Math, and in this video I'm gonna show you how to find the cosine of a matrix, of this particular matrix 0 1 1 0 0 1 0 0 0. So we're taking the cosine of a matrix, not the cosine of the determinant of the matrix. When I posted about this question on my Instagram math page, many people thought that it was the cosine of the determinant of the matrix, and the determinant of this matrix is 0. So many people thought that the answer was 1 because cosine of 0 is 1. But no, we're not taking the cosine of the determinant of the matrix. We're taking the cosine of the matrix. So, well, if you have learned linear algebra, then when you do like the exponentials or the cosine, sine, or the logarithm of the matrix, you would need to like diagonalize or something like that. But here you don't need to diagonalize the matrix because this matrix is special. So first, we will need to use the Maclaurin series expansion of cosine. So cosine of x is equal to the sum from n equals 0 to n equals infinity, or just infinity. From n equals 0 to infinity of this fraction, negative 1 to the nth power, negative 1 to the nth power times x to the 2nth power, x to the 2n, and divided by 2n factorial. 2n factorial. So this is the Maclaurin series of the cosine function, which is basically the Taylor series expansion around x equals 0. So cosine of x is equal to the sum from n equals 0 to infinity of negative 1 to the nth power times x to the 2nth power divided by 2n factorial. And now, okay, first let's let A equals the matrix that is inside the cosine. Let A equals this whole matrix, so that from now on, whenever I mention this matrix, and I just have to say A instead of writing the whole matrix down. So yeah, let's let A equals the matrix 0 1 1 0 0 1 0 0 0. So this is the Maclaurin series of cosine of x, and now let's substitute x equals A, which is the matrix that we're using. So cosine of a matrix A, cosine of a matrix A is equal to the sum from n equals 0 to infinity of negative 1 to the nth power times a to the 2nth power divided by 2n factorial. So this is the Maclaurin series of the cosine function. We just substituted x equals A, which is the matrix that we are using. And now let's expand this sum. If we expand the sum, we would get this is equal to a to the 0th power minus 1/2, because 2 factorial is 2, so 1 over 2 factorial is 1/2. 1 over 2 factorial, or 1 over 2 times a squared plus 1 over 4 factorial. 1 over 4 factorial times a to the 4th power. And I'm not gonna write everything down because it's to infinity, so minus and so on. So cosine of A is equal to the sum from n equals 0 to infinity of negative 1 to the nth power times a to the 2nth power divided by 2n factorial, which is, after we expand the sum, is equal to a to the 0th power minus 1/2 times a squared plus 1 over 4 factorial times a to the 4th power minus ... And so first, a to the 0th power, by definition, sort of, So a to the 0th power by definition is equal to the identity matrix, which is let me paste that matrix A, and then I'm gonna edit this a little bit to make this become the identity. So everyone should know that the identity matrix is the diagonal matrix whose diagonal elements are 1 and the other elements are all 0. I'm sorry, this is taking quite long because the matrix thing is quite complicated, the Latex code. And this, okay, so a to the 0th power is the identity matrix, which is 1 0 0 0 1 0 0 0 1. We're using the third order identity matrix here, which is the 3 by 3 identity matrix, because, well, we're using the 3 by 3 matrix A, so a to the 0th power is the 3 by 3 identity matrix 1 0 0 0 1 0 0 0 1. And okay, then next we need to calculate a squared. So for a squared is not hard to calculate because it's basically just a times a, and then so a squared is a times a, which is equal to, this is just a simple matrix multiplication. You can do it by yourself if you want to. I'm just gonna write the result down. It's pretty easy, it's just simple matrix multiplication. So a squared is a times a, which is equal to this matrix 0 0 1 0 0 0 0 0 0. And so if a squared is equal to this matrix, then you should have some feeling that a cubed and a fourth and a fifth, a to the 5th power, a to the 6th power, and so on will be equal to 0. And let's check that. So a cubed, a to the 3rd power, is equal to a squared times a, is equal to a squared times a, which is equal to, okay, so we know that a squared is that thing that we just calculated, a squared, and then times a cubed is a squared times a, and this is a, and this whole matrix is equal to the 0 matrix. If we do the, you just need to do the matrix multiplication to get the 0 matrix. It's just a simple matrix multiplication. It's nothing difficult here, just doing the multiplication and then you get the 0 matrix. So there you go. We have a to the 0th power, we have a squared. We don't need a because in the cosine, in the Maclaurin series of the cosine function, there's no a term, there's just a to the 0th, a squared, a fourth, and so on. And then a cubed is a squared times a, and we know that a squared is 0 0 1 0 0 0 0 0 0, and then times a, which is 0 1 1 0 0 1 0 0 0. And after doing the matrix multiplication, we get that a cubed is equal to 0, is equal to the 0 matrix, all 0 elements. So now if the a cubed, a to the 3rd power is a 0 matrix, then a to the 4th power is a cubed times a, which is 0 times a, which is 0, and then a to the 5th power, a to the 6th power, a to the 7th power, and so on are all equal to 0. So now the terms a to the 4th power, a to the 6th power, a to the 8th power, and a to the 10th power, and so on in the Maclaurin series expansion of cosine of a will vanish, and the only terms that matter here are the terms a to the 0th power minus 1/2 times a squared. So let me rewrite the cosine of a for this particular matrix that we're using in this problem. So cosine of a is equal to a to the 0th power minus 1/2 times a squared, because all of the other terms vanish, bad English. Okay, so because all of the other terms from a to the 4th power, a to the 6th power, and a to the 8th power, and so on vanish, the only two terms that matter here is cosine of a is equal to a to the 0th power minus 1/2 times a squared for this particular matrix A that we're using in this problem. The matrix A is A equals to 0, 1, 1, 0, 0, 1, 0, 0, 0. So, and we know that A to the 0th power is sort of by definition is equal to the identity matrix, the 3 by 3 identity matrix. And we calculated A squared. And so we just need to plug those things in. And so cosine of A is equal to, alright, so cosine of A is equal to, we know that A is to the 0th power is, let me find it here. Alright, it's the identity matrix, the diagonal matrix with the diagonal elements all 1 and the other elements are all 0, minus 1/2 the identity matrix minus 1/2 times a squared, which is this thing that we calculated here. Where is it? Oh, right here. Alright, so PDF, I hope I typed it right. So alright, so the cosine of A is equal to a to the 0th power minus 1/2 times a squared. And we know that a to the 0th power is this. A to the 0th power is this identity matrix. And a squared is a times a, which is this matrix 0, 0, 1, 0, 0, 0, 0, 0, 0. And then we just need to plug those things in, and then we get cosine of A, cosine of this matrix A. Cosine of A is equal to the identity minus 1/2 times this matrix 0, 0, 1, 0, 0, 0, 0, 0, 0. And then after doing the, just the simple matrix subtraction or addition, like, subtracting is basically adding the minus something. Anyway, so after calculating this thing, we get our final answer for the cosine of A is, alright, I'm gonna copy the original problem. The cosine of A is equal to, alright, so I'm gonna copy and paste this matrix, and then I'm gonna edit it a little bit. Alright, so cosine of A is equal to, this right here is negative 1/2, because 0 minus 1/2. Alright, so yep. Alright, so this is our final answer for cosine of A. So cosine of this matrix, cosine of A, cosine of this matrix 0, 1, 1, 0, 0, 1, 0, 0, 0 is equal to the matrix 1, 0, negative 1/2, 0, 1, 0, and 0, 0, 1. So that's our final answer after doing the matrix subtraction. So if you like my content, please like and subscribe to my channel, and please also follow my Instagram math page with the same name, DVKT Math, and thank you for watching.